Hi, so for today we're going to talk about the elimination of arbitrary constants using the eliminant method or the one that uses determinant in order for us to eliminate the arbitrary constant. So this is basically a continuation of the previous video all about the elimination of arbitrary constants. Okay, so the rule is still the same. In a given function y, we must determine first, okay, how many arbitrary constants are present. And upon determining the determination of the numbers of arbitrary constants, then that's how many times we're going to differentiate the function. So in this case, again, this is our example from the previous video. But in this case, we will be solving this example again that by using the determinant method or the eliminant method. Okay, the answers still should be the same. Okay, so for this problem, again, we have two arbitrary constants. So, therefore, we're going to get or differentiate the function with respect to y, okay, and x, of course, okay, y and x twice. So, we have here what? We have first of all, we need I need to rewrite this equation such that I'm going to transpose y on the negative side or the other side of the equation so that we have negative y plus c sub 1 e raised to negative 2x plus c sub 2 e raised to 3x. So this should be our first equation. And if we differentiate it, again, this would become negative y prime minus 2c sub 1 e raised to negative 2x plus 3c sub 2 e raised to 3x. That is our second equation. Again, differentiating it, we have negative y double prime plus 4c sub 1 e raised to negative 2x plus 9c sub 2 e raised to 3x. So this should be our third equation. Okay, last time, what we did was we used systems of linear equation by elimination method so that we can eliminate c sub 1 and c sub 2. But in this case, we can rewrite this equation actually in a matrix form. So if we write this into a matrix form, okay, 0 equals to the matrix, okay, given by this equation, simply you put it into the matrix. We have negative y prime here, and negative y double prime here. Okay? And again, of course, we have two constants here, c sub 1 and c sub 2. And we are going to write, okay, what is the, let's say, constant, okay, or the term that is actually multiplied by c sub 1, not including the c sub 1, because that's how we write the systems of linear equation in a matrix form, only the coefficients. So, what are we going to do? We have here e raised to negative 2x. Again, from the first equation, we have left c sub 1, so that the remaining is e raised to negative 2x. So, in here, second equation, we have negative 2 e raised to negative 2x. Again, not including again the c sub 1. And for our third equation, we have 4 e raised to negative 2x. Okay? For c sub 2, we have here, for the first equation, not including the c sub 2, we have e raised to 3x. For second equation, we have 3e raised to 3x. For the third, we have 9e raised to 3x. Okay. So, if we can factor out, okay, for the columns, for each of the columns of this matrix, we must do it because it would simplify our matrix. So that if we're going to get the determinant, it would be much easier for us to evaluate those values. So we have here, can I say we can factor out from the column 1, the negative 1. Okay, I can factor that out. Okay, in column 2, we have the column 2 here. Can I factor out e raised to negative 2x? Because all of this equation contains, or all of this expression contains e raised to negative 2x. Okay, how about in c sub 2? Can we factor out e raised to 3x? Yes. So that if we're going to rewrite the equation, or the matrix, the matrix here, we have y prime, y double prime. We have 1 because we factor out e raised to negative 2x, which is this. So, if we factor out e raised to negative 2x, we are left with 1, negative 2. because here is e raised to negative 2x, and we have definitely 4. Okay, for the third column, we have 1 because we factored out e raised to 3x. Okay, and the other one is 3 because we factor out e raised to 3x again, and we have 9. Okay, so now our last step is actually what? Get the determinant. Okay, what is the determinant of this given matrix? So let's try. Determinant is actually denoted by what do you call this? A single line, right? So we have y prime, y double prime. We have 1, negative 2, 4. We have 1, 3, 9. This symbol is to get the determinant of a matrix, the two parallel lines. Okay? And so, if we are going to recall our method of getting the determinant, okay? So, basket method, I don't know if that is correct. We should copy the first two columns, okay? Y double prime, y prime, y double prime. First two columns of the given matrix. And then what we are going to do is to what? We are going to get the sum of the products, okay? The sum of the products of this diagonal plus the sum of the products of this diagonal, sum of the products of this diagonal, and minus the sum of the products of this diagonal. Okay? So let's try. Okay. Let's try again. Okay, I'm going to redo it. So this one, if we get this, okay, what's the product? We have, oops, we have here y times negative 2 times 9. That is what? Negative 18y plus again this one, the product of this. So that should be what? 1 times 3 times y double prime is 3y double prime. Okay, plus again the sum of the product again of this diagonal. So we have 4 times y prime times 1 is simply what? 4y prime. Minus, well, of course, minus this diagonal. Okay? So that should be negative 2y double prime. Okay? This diagonal, 4 times 3, 12 times y. That is plus 12y. And we have 9 times y prime times 1 plus 9y prime. As you can see here, well, of course, this is equal to 0. Okay? This whole equation is equals to 0 because of our because of our equation here. Okay? So, we have here negative 18y combining like terms minus 12y because if we distribute negative sign here, so that would be minus 12y. We have plus 3y double prime, which is this, minus the negative 2y prime, that becomes a plus 2y double prime, plus 4y prime, minus 9y prime, distributing the negative sign. Please be careful with that minus sign. You have to distribute it. So what will happen here? We have negative 18 minus 12y is negative 30y. We have 3y double prime plus 2y double prime is we have 5y double prime. 4y prime minus 9y prime is negative 5y prime is equals to 0. And if we're going to divide the whole equation by 5, what will happen? We have negative 6y plus y double prime minus y prime is equals to 0. In other words, we have an answer of y double prime minus y prime minus 6y is equals to 0, which is the same answer that we get when we evaluate these arbitrary constants or to obtain the DE using elimination on our previous video. So that's how you get the DE by eliminant method. Okay, so let's try to solve again. For number 2, we have this previous example also, y is equal to c sub 1 plus a c sub 2 e raised to 3x. So again, first, rewrite the equation such that the other side is equal to 0. So if I transpose y on the other side, it became negative y plus c sub 1 plus c sub 2 e raised to 3x. That is our first equation. Differentiate, we have two arbitrary constants, so we have to differentiate twice. So we have negative y prime plus 0 because this is a constant plus 3c sub 2 e raised to 3x. That is our second equation. Again, 0. Differentiate again. Y double prime. Derivative of 0 is still 0. Plus 9c sub 2 e raised to 3x. And again, we're going to rewrite this in matrix. Rewriting this on matrix, we have 0 is equals to matrix of negative y prime, negative y double prime. We have 1 because the coefficient of c sub 1 here is 1. Okay? Why did I write 0 here? So that we can see what is the value of c sub 1 on the succeeding derivative. So we have 0 obviously because if we differentiate c sub 1, it is evident that we have a 0 here. And another 0 here for the second derivative or the third equation. And then, what? Again, we have e raised to 3x. We have 3 e raised to 3x and we have 9 e raised to 3x. We have this matrix. Again, taking note that this is c sub 1 and c sub 2. Okay? These are the, let's say, the variables we need to eliminate. Okay, and again, from this matrix, from this given matrix, we can again factor out on the first column, the negative 1. We cannot factor anything on the second column. For the third column, we can factor out what? E raised to 3x because all of these columns contains e raised to 3x. And then, what happens here in our matrix? So, we have y, we have y prime, we have y double prime. We have 1, 0, 0. We have 1, 3, 9. And Viola, if we get the derivative or the determinant of this, okay, do again the process. We have y prime, y double prime. We have 1, 0, 0. We have 1, 3, 9. Copy the first two columns again. We have y prime, y double prime. We have 1, 0, 0. That is, if you get the determinant of that, okay, okay, if you get the determinant of this, that should be equal to 0. Okay, because of the equation. So, again, the sum of the products of the diagonals. So, we have here y times 0. Obviously, that should be, the determinant is here is 0. Okay, plus, again, if we're going to get this, 1 times 3 times y double prime is simply what? 3y double prime. And again, if you get the diagonal of this, sum of the products of this, so we have here y prime times 0 times 1 is simply what? That's correct. That's simply 0. Minus the other diagonal side. So we have y times 0, that is 0. 0 times 3 times y, another 0. Okay? 9 times y prime times 1, that is plus 9y prime is equals to 0. Simplify, we have 3y double prime minus 9y prime is equals to 0. And if you're going to divide this whole equation by 3, so we get an answer of y double prime minus 3y prime is equals to 0, which is the same answer, okay, on the previous video, but we had a different technique on getting the differential equation. That should be our answer for number 2. Okay, let's try again another problem. So, problem number 3. Okay, the only way for you to really do good in math is to practice problems. Okay, to solve more problems. The more problems that you are about to solve or you solve problems, the better. Okay, So there's no other way that you can really be good at math or improve at math rather than solving as many problems as you can. So here we are again. We're going to solve again another problem. By the way, I think I have three problems here. Okay. So this is our problem, third problem. And again, first, rearranging this, okay, such that we have a 0 on the left side of our equation. We have this, okay, expression or equation. We have for the first equation, differentiate negative y prime plus again 0. Okay, this is minus because it is raised to negative 4x. So we have minus 4 c sub 2 e raised to negative 4x. Differentiate again. This is 0 again. This would be 16 c sub 2 e raised to negative 4x. And again, writing it again on a matrix, we have negative y prime, negative y double prime. We have 1, a 0, a 0, same as the problem a while ago. We have e raised to negative 4x. We have negative 4e raised to negative 4x. We have 16 e raised to negative 4x. We can factor out, again, from the first column, negative 1. Second column, we can factor out nothing. For the third column, we can factor out e raised to negative 4x. And if we write again our matrix here, we have y prime, y double prime, 1, 0, 0. And we have what? 1, negative 4, and 16. And now, upon getting the determinant of this, okay, so again, this is equal to 0. Okay, then our determinant would be y prime, y double prime, 1, 0, 0, 1, negative 4, 16. Okay, if you get the determinant, copy the first two columns again so that we can perform the basket method. And again, upon getting the products, this is y times 0 is 0. Okay, so we have now negative 4 y double prime. Okay, so what will happen here? We have negative 4 y double prime. And again, if we are going to continue, 1 times y prime times 0 is simply equal to 0. So minus, again, this diagonal, that is 0. This is 0 again because of the 0. And then we have 16 times y prime, which is 16 y prime. Okay, which is actually equal to 0. So, if we arrange this, we have negative 4 y double prime minus 16 y prime is equals to 0. And again, if we're going to multiply this both sides or divide this by 1 over 4, we have negative y double prime minus 4y prime is equals to 0. And if we multiply it by negative 1 so that we can fix the negative sign here of the y double prime. So we have y double prime plus 4y prime is equals now to 0. So this is our answer for our problem, third problem. Okay, so it's pretty easy, right? If you know how to perform determinants and derivatives as well. Okay, let's try another problem. So let's proceed to number 4, which is a little bit complicated. So we have y is equals to c sub 1 e raised to 2x plus c sub 2 e raised to 3x. Okay, so first things first, 0 is equals to negative y plus c sub 1 e raised to 2x plus c sub 2 e raised to 3x. Differentiate. Negative y prime plus 2c sub 1 e raised to 2x plus 3c sub 2 e raised to 3x. Differentiate again because we have two arbitrary constants here. So we have 0 is equals to negative y double prime plus 4 c sub 1 e raised to 2x plus 9 c sub 2 e raised to 3x. And we need to write this in matrix. Okay, so we have negative y prime, negative y double prime. We have c sub 1 here, we have c sub 2. So we have e raised to 2x, okay? 2e raised to 2x, we have 4e raised to 2x, and we have e raised to 3x here, 3e raised to 3x, okay? And we have 9e raised to 3x, okay? I think this is not so complicated, okay? So it's the same problem that we have encountered a while ago. So we can factor out from each of the column, we have negative 1, column 1. For this column, we can factor out e raised to 2x. For this column, we can factor out e raised to 3x so that our matrix looks like this. So y, negative, or y prime, y double prime. We have 1, 2, 4, and we have 1, 3, 9. Okay? So that we're going to get the derivative, or derivative, the determinant, okay, of this matrix. Okay, so actually we can what? Again, okay, to get the determinant, we have here y prime, y double prime here, and then we have 1, 2, 4 here, 1, 3, 9, copy, okay, let's copy the first two columns. You have y prime, y double prime, we have 1, 2, 4 here, okay. So if we get the determinant of that, again, this is 0 equals to, okay, equals to the determinant here. So let me just change again my pen. So y times 2 times 9 is what? It's actually 18y. Okay? Change again. So we have 1 times 3 times y double prime is actually what? Plus 3y double prime. Okay? And 1 times y prime times 4 is actually 4y prime plus 4y prime minus the opposite diagonal. We have y double prime times 2 times 1 is 2y double prime. This is 4 times 3 times y, that is plus 12y. 9 times y prime times 1 is simply plus 9y prime. Then again, combining like terms, we have 18y minus 12y, distributing the negative sign. Okay, we have plus 3y double prime minus 2y double prime plus 4y prime minus 9y prime. And again, simplifying, we have 6y plus y double prime minus 5y prime. Or in other words, our DE now would be y double prime minus 5y prime. Okay. Oops, I think I made a mistake. Okay. So this should be I think we got it correctly. So our answer should be y double prime minus 5y prime plus 6y is equals to 0. So this should be our differential equation. So let's go now to our last example. So for our last example, we have number 5. We have y is equals to c sub 1 e raised to x plus c sub 2 x e raised to x. Okay? So again, rewrite this equation as this. And again, differentiate negative y prime. So this should be c sub 1 e raised to x. Nothing happens here. Plus c sub 2. Take note that this is a product. X e raised to x. Product rule. So we need to copy this. Multiply by the derivative of this, which is actually e raised to x also. Plus, copy this. E raised to x. Then the derivative of x is simply 1. So that we have this second equation, okay, here. And what will happen is that, again, differentiate, we have negative y double prime plus c sub 1 e raised to x plus c sub 2. The derivative of this is again product. So it happened that the derivative of this is simply this full equation. So I'm going to copy that. Plus, of course, we have to differentiate also this. Notice that when we differentiate this is only the answer. But how about this? So still the derivative of that is plus e raised to x. Okay, the derivative of this. So what will happen? Rearranging the equation or simplifying the equation, we have now x e raised to x plus 2e raised to x. So simply this is our first equation. We have the second equation. We have the third equation. And writing it into our matrix form, we have now negative y prime, negative y double prime. Then we have e raised to x for all of the equation or the rows here or the columns. And what will happen here? For the first equation, we have x e raised to x. Second equation, x e raised to x plus e raised to x. Third equation is x e raised to x plus 2e raised to x. So, again, we can factor out some factors in order for us to easily get the determinant. So, 0 is equals to, we can factor out in the first column, again, negative 1. For the second column, we can factor out e raised to x. Okay? And for the third column, we can also factor out e raised to x. Okay? Because this column has a common e raised to x in it. So by that, our matrix is simply y prime, y double prime, 1, 1, 1, okay, x plus 1, because you factored out e raised to x here, you can get x plus 1. And of course, for the third one, we have x plus 2. And now, we are ready to get the determinant of this matrix in order for us to find the DE of this solution. Copy the first two columns. So we have here 1, 1, 1. And again, perform the determinant. Okay? So what will happen? Y times 1 times x plus 2 is actually what? Okay? X plus 2 times y. Okay? Plus, get the diagonal again. X plus 1 times y double prime. That is simply what? X plus 1 y double prime. Okay, this is plus 1. Plus x times y prime times 1 is simply xy prime. Okay, minus the diagonal again on the upper side. So we have xy double prime plus, okay, 1 times x plus 1 times y, simply x plus 1 times y plus this diagonal, okay, x plus 2 times y prime. So we have x plus 2 times y prime times 1. So we have here the equation. So let me just rewrite it so that we can see it clearly. So we have x plus 2 y plus x plus 1 y double prime plus x y prime minus, distributing the negative sign, we have negative x y double prime minus x plus 1 y minus x plus 2 y prime. Okay? Let me just rewrite this. So we have minus x plus 2 y prime. Okay, we can simplify this by grouping. So we can group y, in this case here, and this, including the negative. So what will happen? We have y, copy this, x plus 2. Okay, distribute the negative sign here. Okay, distribute the negative sign here. So we have minus x minus 1 y. Oh, no. We have already written the y. Okay, so if we're going to simplify it later, plus, okay, y double prime, factor out. So this is the y double prime, and we have y double prime here. So we can copy this, x plus 1, okay, minus the remaining here because we factored out y double prime, this y, this is negative x, okay. So plus x or the y prime because we want to factor out y prime here, and we have y prime here, okay. You factor out y prime here, we have x here, okay. Then distribute the negative sign here, okay. So minus x minus 2. Okay, simplifying, we have x plus 2, x minus x is 0, 2 minus 1 is simply 1. So this is simply y times 1, which is actually y. Okay, this is x minus x cancelled. So we are left with 1 inside. So y double prime times 1 is y double prime. Okay, so if I'm not mistaken. Okay, and then x minus x here. So y prime times negative 2 is negative 2y. So hence, if we rearrange this, we have y double prime. This is okay. This is y prime. Okay, y double prime minus 2y prime plus y is equals to 0. And this should be our differential equation. And I hope you learned something from this video. Thank you so much for listening, and God bless you. This is Engineer Abat.